Good day, students. How are you? Now continue our lesson and consider the second Roman point. Second Roman point. Investigation. 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 Of the given function. Of the given function. Given function. For extremum points, point with help of the second derivative, derivative. Here first the critical points are found, and then the second derivative is calculated, and further calculate the value of the second derivative at the obtained critical points is calculated, and if first derivative at the given critical point is positive, then it means the given critical point is the minimum point. If the second derivative is negative, then the given critical point is the maximum point, and if the second derivative is zero at the given critical point, then we have the indeterminate case. Now write first point is if f 2 prime at x sub 0 is positive, then x sub 0, the critical point x sub 0, which is critical point, then the critical point x sub 0 is the minimum point, minimum point. That is x sub 0 is x sub min. It is minimum point. If f2 prime at x sub 0 is negative, is less than 0, then x sub 0 is maximum point, x sub max. And finally, if f2 prime at x sub 0 is equal to 0, then we have the indeterminate form. We have the indeterminate form case, indeterminate case. Now consider the previous example, the corresponding example. Find the extremum points. Find the extremum points. Of the function the function f of x is equal to 4x prime plus 5x to 4 minus 40x cubed minus 30 with help of the second derivative, with help of the second derivative of the second derivative solution. Please look at the board. First, define the critical points. For this, equalize the first derivative to 0, and then solve the obtained equation. First, find the first derivative. F prime of x equals 20x to 4 plus 20x cubed minus 120x squared then equalize this expression, the first derivative, to 0. Here we can take 20x x squared out the parentheses. 20x squared multiplied by x squared plus x minus 6 is 0. Then find the all roots of the obtained equation. X first is 0, x second is 2, and x third is minus 3. They are the critical points. Then find the second derivative and calculate the second derivative at these critical points. F2 prime of x equals take this expression 80x cubed plus 60x squared minus 240x. Then here we can take 20x out of the brackets, parentheses 20x. Then we have 4x squared plus 3x minus 12. Then calculate the second derivative at these points. F2 prime at 0 equals, it is 0. If substitute 0 instead of x, we will obtain 0. It means we have the indeterminate case. We know whether 0 is the extreme point or no. It is indeterminate form. Indeterminate case. I'm sorry. Indeterminate case. Then take second critical point 2 and calculate the second derivative at 2 equals substitute 2 instead of x. Here for 40 multiplied by it is 16 plus 6 minus 12. It is positive. It means 2 is minimum point. X sub mean is 2. It is minimum point. And finally calculate the second derivative at the last critical point at minus 3. For this substitute minus 3 instead of x, we will obtain minus 16, 36 minus 9 minus 12. The expression in the parentheses is positive, multiplied by negative is negative. It is less than 0, and it means the minus 3 is the maximum point, because the second derivative is negative. And remember that if second derivative at critical point is positive, then this critical point is minimum point. If the second derivative at the critical point, at the given critical point, is negative, then it means this critical point is the maximum point. And if the second derivative at the given critical point is 0, then we have indeterminate form. It is investigation of function for extremum points with help of the second derivative. Please rewrite, please, and look at both. Then go to the third Roman point, named the investigation of the given function for extreme points with help of the higher derivatives. Right? Third Roman point. Investigation of the given function for the extreme points, with help of the higher derivative, with help of the higher derivatives. Here, first find the critical points, and then the higher derivatives values. Are calculated in the obtained critical points, and these values are calculated until the first derivative will not equal to the 0, or different from 0. And then if the first non-zero derivative has the even order, it means our function has extremum. And if this derivative is positive, then we have minimum point. If the derivative is negative, we have the maximum point. But if the first non-zero derivative has the odd order, It means this given point, this given critical point isn't extremum point. Please write these conditions. If the first non-zero derivative has the even order. What is even order? In Azeri it is cüt tertip, in Russian четный порядок. Even order. Then the given critical point is the extremum point. Extremum point. Then we have the two following sub points. Is the extreme point. A. If the first non-zero derivative is positive, if the first non-zero derivative is positive, then we have the minimum point. Minimum point. Minimum point positive. Subpoint B, if negative, write negative. If negative, then maximum point. Negative, then maximum point. Maximum point. Second point. But if the first non-zero has the odd order is in Azeri it is tek tertip. In Russian нечетный порядок. If the odd order then the given critical point has no isn't extremum point. Extremum point. Isn't extreme point. Please rewrite. Now consider the next example in which we will investigate the given function for extreme points with help of the higher derivatives. What is higher derivatives? In Azeri it is yüksek tertip теорема. In Russian, производные высшего порядка. Example. Solve the corresponding example. Find the extremum points. Extremum points of the given function. With help of the higher derivatives. Example. Higher derivatives. Find extreme points with help of the higher derivatives. Write the given function. Take the same function, f of x equals 4x to 5 plus 5x to 4 minus 40x cubed minus 30. Solution. First find the critical point. These critical points are named also the first order critical point because they are the roots of the first derivative. Therefore, these critical points also can be named the first order critical points. First find the critical point. For this, we must find the derivative and then equalize the expression of the first derivative to 0. And further, find the roots of the obtained equation. F prime of x is 20x to 4 plus 20x cubed minus 20x squared, and equalize this the first derivative to 0 for finding the first order critical points. F prime of x is equal to 0. It means this expression is equal to 0. 20x to 4 plus 20x cubed minus 120x squared is 0. Then take 20x squared out of the parentheses, 20x squared divided by x squared plus x minus 6 is 0. And then find the roots of this equation. First root is 0, second root is 2, and third root is minus 3. These values are the critical points, or the also the first order critical point are the critical points. Then open the first point for investigation of 0 for extremum point. Then find the second derivative. F2 prime of x equals, use this expression. 80x cubed plus 60x squared minus 240x. And take, we can factorize this expression, take 20x out of the brackets, out of the parentheses, 20x multiplied by 4x squared plus 3x minus 12 minus 12 minus 12. First point. First, calculate the second derivative at 0, because the first point is 0. f2 prime at 0, already you know that it is 0, because if substitute 0 instead of x, we will obtain 0. It is 0. It means we must continue the corresponding process and find the third derivative, because the second derivative is 0, and we must find derivatives until non-zero, until obtaining non-zero derivative. Then we calculate the third derivative. f3 prime of x equals, use this expression, it is 240x squared, 240x squared plus 120x x and minus 240. Then we can factorize this expression and take 120 out of the parentheses, 120. Then we have 2x squared plus x minus 2. And then calculate the value of third derivative at 0. f3 prime at 0 is 120 multiplied by 0 minus 2, multiplied by minus 2, and it is minus 240 isn't equal to 0. What it means? It means we obtain the non-zero derivative, because the third derivative isn't equal to 0. Its order is 3. Its order is 3. That is, it is odd number. And according to the condition of investigation with help of this high derivatives, if the first non-zero derivative has the odd number, it means the given critical point isn't extremum point. That is, 0 isn't extreme point. X is 0 and isn't extreme point. X, I'm sorry, isn't extreme point. Extreme point. It is an extreme point. Why? Again, repeat. Here, the first non-zero derivative is third derivative. Its order is 3, that is odd number. And according to condition of investigation, if the order of first derivative is the odd number, it means the given critical point isn't extreme point. Then continue. Then continue investigate the second critical point for extremum. Open second point. Now calculate the second derivative at the second critical point. That is, find f2 prime at 2. f2 prime at 2 equals. Then substitute 2 instead of x. It is 40 multiplied by 16 plus 6 minus 12. It is positive, is greater than 0. It is greater than, I'm sorry, it isn't equal to 0. First, isn't equal to 0. It means, what it means? It means the point 2 is extreme point. X is 2 is extreme point. Then we must investigate the type of extremum. Is this point maximum point or minimum point? Then we must look at the sign. Why it is extreme point? Because its order is 2, and 2 is even number. And according to the condition of investigation, for example, of the high derivative, if the order of the first non-zero derivative, because this second derivative is non-zero, its order is the even number. Here the order of this derivative is 2, it is even number. It means the given critical point is the extreme point. But then find the sign of the value of second derivative at this point. F2 prime at 2 here, it is positive, and if this first non-zero derivative is positive, then it means that the given critical point is minimum point. Then it means that x equals 2 is a minimum point. Then open the third point. Then calculate the second derivative at the third critical point. That is, we must find. We must calculate f2 prime at minus 0. Then it means equals substitute minus 3 instead of x in this is in factorized expression. It is factorized expression. 20 multiplied by minus is minus 60 multiplied by here 9 multiplied by 4 is 36 minus 9 minus 12 equals minus 60 multiplied by 15 equals minus 900 isn't equal to 0. What it means? It means that this point, the critical point minus 3, is also extreme point. Why? Because this derivative isn't equal to 0. That is, second derivative is equal to 0, and it is first non-zero derivative. Its order is 2. That is, its order. What is order? Tertip in Azeri. In Russian, порядок производа. If the order is even number, then it means the given critical point is extreme point. That is, x equals minus 3 is extreme point. Now we must investigate for maximum and minimum. And this non-zero derivative is negative. It means minus 3 is maximum point. X equals minus 3 is equal to x maximum. Thus, our function, we investigated the given function for extremum points with several of the higher derivatives, and in final, our function, the given function, has one minimum point, it is 2, one maximum point, it is minus 3, and the 0 is equal to 0 in general isn't the extreme point. Please look at the board. Then please rewrite your homework. Find the extreme points, extreme points of the given function, of the function f of x is equal to 6x to 5 minus 15x to 4 minus 80x cubed plus 50 by I'm sorry, with help of the a second derivative and also higher derivatives. In these cases, we can find only extreme points, but with help of the first derivative, we found also the monotony intervals, the intervals of increase and decrease of function. But with help of the second derivative and high derivative, we can find only the extreme points. Please rewrite homework. Thank you for attention. Good luck. Goodbye, students.